Hello. In this video, we're going to look at building polynomials given the zeros. As we saw last time, the factored form of a polynomial gives us a lot of information about what the polynomial will look like. And it's really these zeros of the polynomial that give us the most information. We can work backwards, given the zero and its multiplicity, in order to build or construct these polynomials. So, the first example, find a polynomial of degree 5 that has the following zeros. So we see -8 with multiplicity 2, -4, 1, and 5. So what we're going to do is say, okay, I have f of x. It will be something x minus -8. And they said this multiplicity is 2. X minus -4. Multiplicity 1. Since they didn't say anything, we just assume that. X minus 1 and x minus 5. And this makes sense because with it being degree 5, we wanted to make sure that the sum of these multiplicities is 5. Okay. So now we don't know what a is, but it says find a polynomial. And what that means is we could switch out a for anything. 1, 2, 3, 4, 5, 6, 1/2, 1/3, 1/4. It doesn't matter. So I'm going to make the nicest polynomial with these zeros, with a as 1. So rewriting this into a nicer form, I see it's x plus 8 squared, x plus 4, x minus 1, and x minus 5. Now, since this function, we can graph a lot of it from this factored form, we won't normally need to multiply it all out to put it into general form. But let's just practice graphing these functions based on this polynomial that we've constructed. We have 4 distinct zeros. At -8, -4, 1, and 5. My end behavior, so it's degree 5, so it's odd. And I chose my a to be positive, so it looks like x. And then we can look at what is it doing at each of these points. At x plus 8 or at -8, it's touching. And then at the rest, it's going through it. So if I start to draw this now, we can see I have this, and then it has to touch. So it must come back at some point and go through. So it has to come down and go through at some point, and then up. So again, just based on the touch, through, for the zeros, and that end behavior, I have a general idea of what the graph looks like. All right. So we could have an equation or a question where it makes us find the polynomial and it gives us some point. So let's do what we did before. So we put it in this form, and it tells us that f of 2 is 20. Well, if f of 2 is 20, that means by plugging 2, I should get 20. And when we do that, we realize that we can solve for a now. So a is negative 20 over 8, which can reduce to negative 5 over 2. So what that says is my original equation, my actual polynomial, is negative 5 over 2 times these zeros. So once we have the zeros and another point, it's very easy to solve and construct an equation. And that's everything that we're going to need for polynomials.